I'm going to look just to the right of x equals 5, but not all the way to 5 square root of 3, of course. So I'm going to look at x equals 6, and I see that that's also negative, right? 1/3 times 6 squared, 1/3 times 36 is again around 12. Minus 25, that's negative. Denominator is always positive, so that's a negative number. So the function is concave down from 5 to 5 square root of 3 also. Okay, so then no change in concavity. Now I'm going to look to the right of x equals 5 square root of 3. I'm going to look at x equals 10. And I see that, oh, the second derivative now become positive, which means it's now concave up again. So from that last possible inflection point, 5 square root of 3 to infinity. Okay, so that means that we do have an inflection point at 5 square root of 3, just like we had an inflection point at minus 5 square root of 3. But we do not have inflection points at x equals plus or minus 5. Okay, and that's what I say here. And so I wrote down the concave up on the intervals, minus infinity to minus 5 square root of 3, union 5 square root of 3 to infinity. But it's concave down on minus 5 square root of 3 to minus 5, union minus 5 to 5, union 5 to 5 square root of 3. And those are all open, of course. Right at the second derivative being 0 or being undefined, it's neither concave up or down. It's either a change or some other problem. Okay, so the only thing left to determine is whether the critical points give us a local maximum, minimum, or neither. Since the second derivative existed at x equals 0, I used it up and above to look at concavity, and it told us in our work above that the function was concave down at that point. Then we know from the second derivative test that there's a local maximum at the critical point that we found, x equals 0. Remember, the critical point was where the first derivative was 0 or does not exist, and x equals 0 was one of those. So the value of that local maximum, I have to plug in 0 to the actual function to see what the function value was at that local maximum. So it's 9/13, it would have been 0 squared minus 25, so just minus 25 to the 2/3 power. So 9/13 times, and 25, minus 25 squared, let's look at it that way. That's the negative 1 becomes positive 1, right, when I square that. So then it's 25 times 25, but that's 5 squared times 5 squared. So it's 5 to the 4th. So 5 to the 4th is 5 cubed times 5. So the cube root of 5 cubed is 5, and I'm left with another 5. So it's a cube root of 5. 5 times the cube root of 5. So the exact value of that is 45 divided by 13 times the cube root of 5. And if you put that in your calculator, you can see it's about 5.9191. I cut it off at 4 decimal places. So we can't use that second derivative test, though, for the other two critical points, x equals plus or minus 5. You have to actually check the sign of the first derivative to the left and to the right of these critical points to determine whether they represent local minimum, maximum, or neither. So just to the left of x equals negative 5, we'll check x equals negative 6, the first derivative at negative 6. Plug in negative 6. Remember, it was x here, x squared minus 25 to the 1/3 here. So that's negative 6 is negative. This guy is 36 minus 25, which is positive. Positive number, cube root of a positive number is positive. So that's negative over positive, which is negative. So that means the function is decreasing on minus infinity to minus 5. So to the right of minus 5, let's check x equals minus 4. Y prime then of minus 4, plug in minus 4, you get minus 4 over. Now this is 16 minus 25, which is minus 9. The cube root of minus 9 would be a negative number. So a negative number divided by a negative number is actually a positive number. So that means the function is increasing on minus 5 to 0. Oh, so that means we have a local minimum, right? It's decreasing until we get to x equals minus 5, and then it's increasing, so we have a local minimum at x equals minus 5. And then if you want to know what the actual value of that local minimum is, you just plug the x equals minus 5 into the function, which is that simple. It comes out to be 0. And if you remember from the picture of the graph, that makes sense. So then we have to check x equals 5. So just to the left and just to the right, you plug in x equals 4 and x equals 6. If you plug in x equals 4, you get positive over negative, right? 16 minus 25 is negative. Cube root of negative 9 is negative. Positive over negative is negative, which means it's decreasing on 0 to 5. Plug in 6. Y prime of 6 is now positive, which means it's increasing on 5 to infinity. So again, we have a local minimum at this time at x equals 5 also. It's also minimum. And its value is y equals f of 5, which is 0 also. So that should be good enough to go through and put all the answers in, make sure they work right. Hopefully I haven't been out of this too long where it's logged out on me. So I already clicked on this, I was playing with it. The inflection points is or are, so it says type an ordered pair. Use a comma to separate answers. So it wants our two values of x. Okay, so it actually wants the ordered pair. It wants the function. It wants the It wants the value of the y value for each of those inflection points too. Let's see if that's easy or not. So the inflection points are minus 5 square root of 3 and 5 square root of 3. We found them to be. So if I plug in 5 square root of 3, that's going to be what? If I square that, I get 25 times 3 is 75. 75 minus 25 is 50. Whether I plugged in minus 5 square root of 3 or 5 square root of 3. So this is 50 to the 2/3 power. Okay. So 50 squared. Cube root of 50 squared. Let's see, is that an easy number? It doesn't seem like it's going to be an easy number, does it? So let's see, 50 squared is 50 times 50, which is 25 times 2 times 25 times 2. Doesn't seem like it's going to be an easy number for me to just figure it out, is it? Thought it would be. 50 cube root of, and that's 2,500. 50 times 50 is 2,500. So 25 times 100. Again, it's nothing easy. Darn it, I'm wasting time on the video. Sorry. All right, so let's see. If I plug in these values, what happens here? Actually, let me just show you the completed problem. It changed the problem on me. I was off of it too long. Sorry. But it does want you to put in the y value. So we would have put in 9/13 times the cubed root of 50 squared, which would have been 2,500. Cube root of 2,500 for us. So it changed the problem. Sorry, I've been off of that problem too long while I was typing it up, so I can't put in the answers for you. But anyways, that's how you go about and do it. Okay. I had number one with much harder numbers than this, so if you got these numbers, they work out easy, but it's all the same idea. Okay, this you just get randomized numbers. Hope that helps everybody.